have 2.28. Okay, 28. We have 3.37. We have 1.99. 8 rounded to 2 decimal places is 2.00. Okay. We have 0.75, which is that rounded to 2 decimal places, and then finally we have 0.07. 0.07 rounded to 2 decimal places. Okay. So effectively what we've done here is that we've calculated this particular value for each one of our cells in our contingency table. Now what we need to do is we need to sum these up. So our chi-squared test statistic is the sum of all of these values here. Okay? So it's 1.42 plus 0.70, okay? Plus 2.68, okay? plus 0.01 plus 2.28 plus 3.37 plus 2.00 plus 0.75 plus 0.07 gives us a total test statistic of approximately 13.28. So our test statistic is 13.28. Okay, so we're nearly there now. Okay, we've just got one or two things left to do. I suppose what we've calculated now is we've defined our hypothesis. Okay, we've defined our significance level. We've calculated our test statistic, and I suppose what's left to do now in a moment is I just need to slide this under here, otherwise we will lose some of the camera might go if there's too much light shining up upon it. Okay, so what we'll do now is we need to calculate our critical values. Okay, so part 4 is our critical values for this particular test. Okay, now don't forget this is a chi-square distribution, so it's positively skewed depending on the degrees of freedom. It's a one-tail test. Actually, let's think about this. What value would we get for our test statistic if there was no difference between the observed and the expected? Well, if there was no difference, this would be 0 and this would be a particular value. So the sum of the test statistic would be effectively 0 if there was no difference between what we've observed and what we'd expect to happen under the null hypothesis. There would be no difference between them. Okay. So actually the test statistic, here is 0 here. Okay, this is my chi-squared distribution. Okay, so if it's 0, it means that there's no difference, but we're trying to find out whether there's a difference. So it's just a single tail test. We're actually putting 0.05 of the area in the right hand tail. So what we're going to do is we're going to go to our tables, our chi-square tables, where we have 0.05 in the right tail, and we're going to look up our degrees of freedom. Okay. Now, the degrees of freedom for this test is the number of columns. It's the number of rows minus 1 times the number of columns minus 1. Okay. The number of, it's the number of levels of measurement in our two independent variables minus 1 in both cases, and it's the product of them. So the age variable has 3 levels of measurement associated with it. The brand variable has 3 levels of measurement associated with it. So this is a 3 by 3 table. So actually what we need to do is 3 minus 1 gives us 2, and 3 minus 1 gives us 2. So actually what we end up with is 4 degrees of freedom. Now the critical value associated with 4 degrees of freedom on a chi-square distribution with 0.05 of the area in the right tail. Okay, we've got tables that we've set up for this. I must actually put these tables up online. 4 degrees of freedom and 0.05 in the right hand tail gives me 11.143. 11.143. So actually, if we were to interpret this, okay, so this value here, this critical value here, is equal to 11.143. Okay. Now, our test statistic, actually, what we're saying here is this: is that if the null hypothesis is true, we'd expect a test statistic down around 0, down around here. Okay. Okay. And we've set the significance level of 0.05. In other words, we need to be that far away from here for us to be able to infer that there's a difference. Okay, in other words, for us to be able to reject the null in favor of the alternative, and that's what this significance is all about. Now, our test statistic is 13.28, which is in here. It's in the rejection region. Yeah, that's our test statistic in there. Okay, so our decision is this. Our decision, step 5. Our decision. Okay, well, clearly, our test statistic, which is our chi-squared statistic, is bigger than our critical value. What do I mean by that? I mean that 13.28 is bigger than our critical value of 11.43. In other words, it's bigger than it. It falls in the right-hand tail. Okay, and as such, we reject H0. Okay, at the 5% level of significance. Okay, so we're rejecting. Okay, we're rejecting H0. Okay, and now we can make the inference. Once you reject, we can make the inference and infer. Okay, that's the two variables are dependent. What does that even mean? Okay, well, what it means is this. In other words, a person's age, okay, influences, okay, the brand of mobile phone, that they choose, if that makes sense. Okay, well, guys, that's it all done. That's that particular test. There's nothing else to it. All we need to do the test is we need to calculate these observed and these expected frequencies. Okay, we've done that. Okay, the observed and the expected frequencies. Okay, and then we just take them away to calculate. Well, our chi-square test is the observed minus the expected squared relative to the expected, and we sum them up over all the possible differences. Okay, guys, I hope this video on hypothesis testing and the chi-square test of independence was helpful for you. Once again, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and thanks for watching this. Okay, bye bye.